Today, I'll give you a demo of enhanced file heatmap feature in Archie AI. Archie AI helps you understand code-based 10x faster. So, guardrails repo, I just copied their URL and you can add it from here. So this repo already exists here in my repository, which is here. So what guardrails is about is if you're writing LLM application, they help you write it better. Like they have some Python validators, so you can validate the input and output, do transformation, and that is pretty helpful. And you can use this summary that we present to understand how they do, how they implement the validation here. But one of the feature I want to talk about today was this file heat map feature. So this gives that in a code base in the last 10,000 commits, which file have changed a lot. And the logic being that if some file is changing frequently, it means that it's critical to business logic and could be the first place where you start understanding the code base. For example, this validators.py has changed like close to 100 plus times in the last 10,000 commits. And maybe it contains the main code logic. So we first give you an overview that which are the top files. For example, this guard.py, this contains the main logic as you can read it. Validators.py, which we looked at, handle the validation logic. And we also give you the link from where you can directly go to the file in some cases. And then for top files, you will also see a detailed view. For example, for guard.py, you can see the text diagram of which function is calling which function. So if you could see that the main function here, it's define a class which is guard, and there is init method, there is from rail and other method to create it, and for each how it's happening. It also defines the data flow that the guard class initialized, and it has this class method from rail, from pydantic, all of these. And for each function it also gives that what are some inputs and output. So that's for this file. Similarly for validated.py, uh, so it seems that this defines a class which is get llm ask. And then mostly for OpenAI, Cohere, Anthropic, and all the models, it has implementation of it. And now you can understand that what it's trying to do. So overall, the provided code is set of wrappers and utility function for interacting with various LLM, which I presume is a way that makes it easy for you to write validators. Get LLM ask, get async LLM ask are used to create appropriate prompt callable base class. So yeah, how do you they change the prompt to make things easy for you. So for all of this, you get a really nice sort of function map to understand what are the top function. You can understand that what each of these functions is about. So this can give you a very nice overview of like what are the top files. And if you have any question about some particular files, you can also go back and ask in our chat here. For example, this file, guardrails.py. So you can also go here and search guardrails dot py. Uh, Sometimes we have to be very precise. So these are the top functions in here in the guardrails guard.py file. For example, let's say let's look at one function. That what is this? From rail string function. So I'll save this chain and say explain this function to me. In doing so, give a simple code that I can run in Notebook to understand. So this is a nice trick that I always do, which is ask a code that I can run on Notebook that can help me understand it better. So pick that file and that particular function, and then it's writing explanation. So yeah, the idea is that user would define a .rail string file, and it can create the guard class from that. So this makes it really easy for user to maybe define a text file similar to how when you define Kubernetes and you all container, you define the Docker file or you define the YAML file, and this gives that what this file is about. And then it gives a simple code that I can run on the notebook. So for example, what is this? It defines that if it's a string, return create class from this string, and similarly from list, and then its init method and all, and then it gives you input and output to understand. Now you would also want to go and look at the real code and then understand how much simplification it is done, but this will give you a nice tool to dive deeper. And if you have any follow-up question, you can ask here.